Okay, so in the last lecture we started the discussion of Newton's laws of motion, okay, and I told you about we were talking about the different kinds of forces, right? Now forces can also be of two types, contact and non-contact forces, okay. In the last class I talked about the gravitational force and the normal force. So gravitational force is a non-contact force. A object can be anywhere in air, its weight will act downward, okay. So there is no need of contact of that force. So, and non-contact forces. So already contact means, as the word suggests, the forces which act when the object is in contact with something, right? So the example of non-contact force is gravitational force. And the example of contact force is the normal force, which we talked about in the last class. Because normal force will act on an object only when it is in the contact with the surface, okay, and the normal force will always be perpendicular to the surface. These are the two important things which one has to remember. Now today I am going to talk about another very important contact force which you will see all around you, okay, and that is a frictional force. So that is another example of contact force. Okay, the most important point for the frictional force is that it always acts parallel to the surface, okay, and it will act when the object is in contact with the surface. So this is perpendicular to the surface, this is parallel to the surface, okay. These are signs of perpendicular and parallel, and these are gravitational forces. Now let us talk in detail and try to understand what is a frictional force, right? Now I'll give you a question. For example, if there is a table in your room and a book is kept on the table, okay, or any box is kept on the table of some mass m. Now you tell me, you can pause the video here, okay, after I pose the question. Think and tell me whether there will be any frictional force on this object or not. Okay, many students, they have a wrong intuition about this concept. Think that, first of all, you think what are the different forces acting on this object. We have already studied two types of forces. First, the gravitational force will act on this object, then the surface will apply normal force, right? And this object is at rest. So when the object is at rest, and we have already understood Newton's first law of motion, that we require an unbalanced force to move the object, right? If the object is at rest, it means the forces are balanced. So normal force is balanced with the gravitational force. Now think and tell me whether there is a frictional force on this object or not. Okay, now we will think this in a different way. Let us take there is a frictional force, okay. In which direction frictional force will act? Frictional force will act parallel to the surface, right? So we can take any direction. Later on we'll try to figure out what should be the direction of the frictional force. So let me take this direction to be the frictional force. Let us take there is a frictional force, okay, and what case I am taking? An object is kept at rest on the table. Now let us argue whether what we have thought is that there is a frictional force, that is correct or not, okay. If there is a frictional force, there is no other force acting on this object, right? Then there will be a net unbalanced force in the horizontal direction if there is a friction force. And if there is a net unbalanced force, then what will happen? The book will start moving towards left. It should move according to Newton's first law. That's what we have learned in the last lecture, right? So, but this is not happening. It means that this, if the book is at rest and I am not touching that book, I am not applying any book, then there cannot be any frictional force acting on the book. So, this statement is wrong. There is no frictional force acting on the book if we are not touching it, or if any external force is not applied. It means that whenever I apply a force on the book, whenever we apply any external force on the object, then only friction force comes into picture. Can you think of any case when there is no external force applied on object but still friction force can be there? Again, you can pause the video and think. Okay, so the question is, first question is, if an object is kept at rest on the table, then we just argued there cannot be any frictional force acting on the book, right? But is there any case when there can be the frictional force without any external force acts on it? Yes. For example, if any object is moving and while in the motion it comes in contact with some surface, then what will happen? After some time, after it will come to rest, then the friction force will act on that object, right? So here what we have argued, that if the object is at rest, then, and if there is no applied force, there cannot be any frictional force. Okay, I hope this point is clear. Now what do I do? So there is no frictional force acting on the book if any external force is not applied on it. Okay, if there is no external force, okay, book, if there is no external force applied on it. Okay, so no external force, no frictional force. Now what happens? I start applying some force on this book, but I am not able to move the book. Okay, so what I am going to do? This is case 1. Now case 2, I apply some force on this book, okay, of mass m. Now I am not marking again and again gravitational and the normal force, they both are balanced. I am just talking about the forces in the x direction. There is a force F1 I apply, but I am not able to move the book, okay. The book is still at rest. Now, is there a frictional force acting on the book? Yes, it has to be, because the book is at rest and the forces, they have to be balanced, right? So that the book is at rest. So then there will be some frictional force acting on the book, right, in the opposite direction to the applied force, right? And how much frictional force will be there? This frictional force will be equal to the applied force. So in this case, this frictional force will be equal to the applied force. Okay, what actually is the frictional force? Frictional force is basically when the object is kept on the surface, okay, so the object, it is making some contact with the surface, okay, like this. So you can just imagine all the atoms of the object, okay, they are making a connection with the atoms of the surface, right, like this. So this is the frictional force which gives rise to it. Now here, in this case, whatever force you apply, that will be the same as the frictional force, right? Now what do? If I increase the force which I apply, but still I am not able to move the box. Another case, what do? I apply now F2, where F2 is greater than F1, but still book is at rest. How much will be the frictional force now on the book? F2, it has to be, right? So now the frictional force, this frictional force, I am denoting this by Fs, okay? This frictional force Fs will be equal to F2. Why? Because it has increased, because the book is still at rest. So what is the important learning from this? That this frictional force is not constant. It is increasing as you are increasing the applied force, okay? But there is a limit, okay? So what is that limit? That limit will depend upon the normal force. Why? Because if the object is very heavy, more will be the gravitational force acting downward, right? And if the gravitational force is more is the normal force, okay? So indirectly, so basically the amount of force which the surface will apply on the object, that will determine the limiting value of the frictional force. And this frictional force, till the object is not moving, is called as static frictional force, okay? So the frictional force which acts till the time the object is not moving is called static frictional force. Now, and this is changing, this is called static frictional force, okay? The force which acts when the object is not moving. Now I argued that there is a maximum value of frictional force, and this maximum value has to be less than or equal to, or first directly proportional to the n, or normal force. I have written normal force, okay? Once I remove this proportionality sign, I should get a constant, right? So when I remove this, and this is less than or equal to mu s into Fn. Now let us understand this. Mu s is called coefficient static friction, and it is the property of the surface, body and the surface, okay? And this is an experimental value which you cannot calculate, that will be given to you by the experiment. Now what is the meaning of this? As the normal force is increasing, the static frictional force will, the maximum value up to which the static friction can go, that will increase, right? Because what happens, if there is a very heavy box kept on the table, then you apply some force, you are not able to move, you apply some force, you are not able to move, and the static frictional force will also keep on increasing, but there will be a limit. When you apply force more than that, you will be able to move the box, right? So that limiting value of the static frictional force up to which it can go, that is given by mu s into Fn. Mu s is the coefficient of static friction and the normal force. So if there are two boxes of 5 kg and 10 kg, then 10 kg you have to apply much more force to move 10 kg box. So the maximum limiting static friction for the 10 kg will be more, obviously, right? So the value up to which the static friction can go, that will depend upon the normal force, and normal force basically it depends upon the weight of an object. right? So more the weight of an object, more stronger will be the bond between the object and the surface, right? We say more is the surface, more surface is rough. Okay, now this is the maximum static frictional force. Once, now if you apply more than the force, more than the maximum value of static frictional force, you will be able to move the object. So if applied force is greater than the maximum value of the static frictional force, then the object will move. Okay, I hope this point is clear. Right? And once the object is moving, frictional force is still there, right? But we call that as kinetic friction, and the value of kinetic friction is little less than the static friction value. Okay? Then the object will move. The frictional force is still there when the object is moving. And it is called as, and it is known as kinetic friction. Okay, kinetic friction force, and this is denoted by Fk. Its value is mu k into normal force, where mu k is, its value is fixed, it is not changing. Okay, static frictional force will change, and mu k is called coefficient of kinetic friction. Its value is fixed, okay, and it depends upon again the normal force. So what we have learned, there are two coefficients, coefficient of static friction and coefficient of kinetic friction. Okay, till the object is not moving, the friction present is called static frictional force, and it is changing. It has a maximum value which is less than and equal to mu s into normal force, and when the applied force is more than that, the object will move. And while the object is in motion, the friction which is present, that is called as kinetic friction, and its value is given by mu k into normal force. Okay, I hope this point is clear. So the two types of frictional forces. So whenever you do the problems in which the object is in motion, you have to always consider the kinetic frictional force. Okay, so let us do one problem and see how to apply this concept in solving the problem. Okay, so let us do one problem. A block of mass, okay, once I write the problem, then you all can just pause the video and try to solve. Rest on a rough, okay, when I say it's a rough horizontal surface, it means there is a friction. Rough horizontal surface. The coefficients of friction are mu k is equal to 0.5 and mu s is, the value of mu k is always less than the value of the coefficient of static friction, okay, as I told you, because that will be used when the object is moving. In a horizontal force, F is applied. ठीक है? A block of mass 2 kg rests on a rough horizontal surface. The coefficient of friction are mu s and mu k. A horizontal force of F is applied. Okay. Now what is the question? If F is 8 Newton, what frictional force X on the block? Now, how do we calculate that? First of all, we have to calculate, we don't know at present that whether the object is able to move or not. In order to check that, what we have to do? We have to first calculate the maximum value of static friction, that up to what value the static friction can go, right? Because then only we can check if that value is greater than the applied force, the object will not move. But if I am applying more force than the maximum value of static friction, the object will move. So in order to check whether the object will move or not, that will depend upon the maximum value of static friction. Okay, so let us see. First of all, let us calculate the normal force. Okay, how much will be the normal force? So on this, let us first take the gravitational force, that will be equal to m into g. The gravitational force will be 2 into 9.8 newtons, 19.6 newtons, correct? And that will be equal to the normal force. So in this case, normal force will be equal to the gravitational force, because there is no other force in the vertical direction. That will be equal to m into g, 2 kg into 9.8 meter per second square, 19.6 kg meter per second square is newtons, right? Now, what is the maximum value of static frictional force? That is given by mu s into the normal force. Mu s is how much? 0.5. 0.5. These coefficients will not have any units, okay? These are just numbers. 19.6. And obviously, mu s is Fs maximum. It will have units, dimensions of force. This will also have dimensions of force. So mu s is just the ratio of two forces. So it will not have any dimensions, okay? It's a dimensionless quantity. So this will be equal to 9.8 newtons, okay? This is the maximum value of static friction which this surface can offer. Now, how much force I am applying? I am applying 8 newtons. So 8 Newton is less than 9.8 Newton or more? Less than 9.8 Newton. It means I will not be able to move the object. And how much will be the frictional force? When the object will not move, the forces, they have to be balanced. I am applying 8 Newton. Frictional force will also be 8 Newton. Okay. So F is less than maximum value. So the object will not move. Okay. And how much will be the frictional force? Frictional force will be 8 newtons. I hope this point is clear. Okay, why? The frictional force is not 9.8. That is the maximum value of the static friction up to which it can go. Okay, but I am applying only 8 newtons. So, and when the object is not moving, frictional force has to be equal to the applied force. So, the frictional force will be 8 Newton. Now, second part, okay. If the applied force is 12 newtons, then let us check that whether I will be able to move the object or not. Okay, let me change the slide. Okay, you might have note down. So, I will draw the diagram again. So, there was an object of 2 kg. Okay, mu s was 0.5 and mu k is 0.3. Now, applied force F. So, what is the second bit? This is applied force F, 12 newtons. Okay, then we have to find what friction force X on the block. Okay, acts on the object. So already we have calculated the value of Fx maximum, that is from the previous calculation 9.8 Newton, and now 12 is F is greater than Fs maximum. Then what will happen? The object will move. Now you tell me that how much will be the frictional force in this case? Now the applied force is more than the Fs maximum. Frictional force will not be there this much because now the object is moving. And what kind of frictional force will act on the object if the object is moving? Kinetic friction. So the object will move. The kinetic friction force Fk is given by mu k into normal force 0.3 into normal force was how much? 19.6 newtons. Okay, if I solve this I will get 5.88 newtons. Correct? I hope this is correct. So 19.6 multiply 0.3. Okay, 5.88 newtons. So when the object is moving, when I am applying 12 newtons, then how much frictional force is there? It is not 9.8 newtons. That is again the maximum value of static friction which can act. Okay. So when the object is moving, you have to calculate the kinetic frictional force, and this is the force which will act on the object. And now if I ask you to calculate the acceleration of an object by using Newton's second law, then how do we do? In order to find acceleration of the object, find the acceleration of the object. Okay, so in order to find the acceleration of the object, so here Fk is this much, right? Here because the object will move. In order to find the acceleration, what are the forces acting on the object? 2 kg. The applied force is 12 Newton. How much is the frictional force? 5.88 Newton. Okay. We have to find the acceleration in the horizontal direction. So in order to find the acceleration, F net over m. How much will be the net force? 12 newtons minus 5.88 newtons over 2 kg. That will be equal to 6.12 newtons over 2 kg. That will be equal to 3.06 meter per second square. So this problem is very important, so that you understand the concept of static and kinetic friction. Okay, what we have done, if there is a rough surface and I am applying some force, then the frictional force will come into picture. Okay, till the time I am not able to move the object, the frictional force which will act on the object between object and surface, that will be static frictional force. And as you keep on increasing the applied force, the static frictional force will also increase, right? But there is a limit, and that limit of the static frictional force depends upon the normal force. Okay. So what is the formula what we have used? Mu s. So for the maximum static frictional force, the formula is mu s into the normal force. Okay, by using where mu s is the coefficient of static friction. Now if you apply the force, so by calculating this you can check whether you will be able to move the object or not. If the applied force is more than this value, the object will move, right? Once the object is moving, frictional force is still there, but now it is kinetic frictional force, which is little less than the static frictional force. Okay, and that you will calculate by using mu k into normal force, right? Now you calculate the frictional force And in order to find the acceleration, what are the different forces acting on the body in horizontal direction? 12 Newton is the applied force. This is the kinetic frictional force. So whenever objects are moving, always you will take kinetic frictional force. And then F net divided by M, I am taking all the magnitudes. 12 Newton minus 5.88 Newton over 2 kg, that will give you 3.06 meter per second square. Okay. I hope the concept of frictional force is clear to all of you. Okay, we'll do many more problems, okay, where there can be an inclined plane where friction is acting, there can be connected bodies. Okay, we can just keep on adding the complications and we can do many problems by using the concept. The concept remains the same. Okay, if the applied force is acting at an angle, okay, we'll also do that problem. Then you have to resolve the force into two components. In that case, normal force will change, and in that case, maximum value of static friction will also change, because that will depend upon the normal force. Okay, so see you in the next lecture.